Hello, welcome back to Lorenzo's KSP for Idiots, episode 2. I wasn't initially planning to do a multi-part series of this series, but the response to episode 1 was very positive, so I'm going to go on and make a few more episodes. Today we'll be looking at decouplers and various techniques for setting up the staging to make use of them. To do this, I've made a little rocket here, and it looks silly, it looks ridiculous. Don't pay any attention to it. It's got the capsule, it's got the bigger 3-man capsule, it's got 3 Kermans in it, a parachute on top and a big fuel tank that does nothing, a big adapter that does nothing, and one tiny rocket underneath. I've made it like this, and I can call it the idiotic booster. I've made it like this so to make sure that this booster does not immediately shoot off into space, and I can demonstrate the effects of different kinds of staging. Speaking of staging, look at the right here. We have the booster first and then the capsule and the parachute second. For all intents and purposes, these things are just ballast. We will be trying to lift this up. So, if we go to the launch pad, we can see how that goes. And this is basically the most simple rocket you can get. A booster, a capsule, and a parachute. If you were trying to do something, you'd omit the ballast, but we aren't, so we're going to take some ballast up. Pretend this is a science bay, or whatever you need taken up in orbit. So we're going to launch the rocket, and we see how it does. It's got the one booster, no staging, no separators, nothing. So if we look at this rocket, is going up steadily, leaving a nice trail of smoke and fire, but we can already see this is not going to go very far. The booster is almost run out. Look at the left here to see the fuel remaining, or in the fuel display here. Disregard this liquid fuel and oxidizers, this is our ballast, and we see the rocket burns out at about 2.5 kilometers of altitude, and by looking on the map view you can see your trajectory. The apoapsis, or highest point, is about 3.5 kilometers. So with one booster, we make it to 3.5 kilometers. Well, we want to go higher, of course, and this leaves us with a question to answer. We want to add more rockets, but how are we going to go about it? If we want to add just one more booster, we can't very well just slap it on the side like this, because if we do that, then this happens. Let's have a look at what happens if we just add the one booster willy-nilly. If we launch it like this, then this happens. Explosions and disasters. So we can't very well do that, which I've explained in a previous video as well. If you want to add things to the side, you want to make them symmetrical. So we use the symmetry tool here in the lower left, and we might add 2 boosters here. So if we do this, let's have a look how that goes. So the rocket is going up, this time with 3 boosters, and it's going up a fair bit quicker than it was with just the one. However, there is a limit to this strategy, as we can add more and more boosters all around the rocket. We will start going faster, but our burn time is not going to go any higher. And because we are in an atmosphere, it doesn't make much sense to apply all the rocket power from the start immediately. So here, these 3 boosters, they burn out at about 8 kilometers, and looking at the map view, our apoapsis is now at about 18 kilometers. It's falling because we are going through air, which is slowing us down. Now, if we were to add more and more and more boosters, we would keep on going faster until we are streaking through the air, the lower air, so fast that the rocket will actually burn up and disintegrate. This is not something we want to do. We want to do it differently. We want to add the boosters in such a way that they fire one after another. Now we could do it like this, but this video is about decouplers, so let me show you the decouplers. They're in the structural tab here on the left, and we have a lot of things here. We have the adapters, the heat shields, more and more stuff than you could possibly need, but we are looking for the decouplers. Going on the second tab here, this is the Rocco Max adapter. This is the larger one. We are looking for the smaller one. This is here on the last page, the TR18A stack decoupler. This is what we want. So if we put this under our solid booster, then we can put another booster under that, and this will separate these stacks, allowing us to fire them in sequence. So first stage then becomes the bottom one, the second stage the decoupler and the next one, or we could even separate them in different stages again. So we have the booster, then a decoupler, and then in the next stage another booster. Now we can have a look and see how this goes. We have now made an inline stage. This means the stages fire one after the other. The drawback to this is, of course, that you are carrying a rocket up that is not actually firing. So the initial ascent will be slower, but then you get a second rocket which will carry you higher again. So let's see how this goes by launching this rocket. See, the liftoff is very slow. We have to carry all this ballast, the second rocket, and this one has to do all the work. We're still launching with just one booster, but we now have a second booster in reserve, as it were. So as we wait for this one to burn out, we are preparing to hit the stage, the spacebar key, that will separate the burnt out decoupler, and then hit space another time. That will fire up, initiate the second booster. So here we go, jettison that and fire up the second booster. Now this is basically the same rocket that we launched in the first attempt, just with the one booster, except it's now already 1.5 kilometers in the air and it's moving at a fairly decent speed already. If we recall, the rocket with just the one booster made it to about 3.5 kilometer apoapsis. Now we're at 3.5 kilometers already, and we're still boosting. So this is definitely going a lot better than the first test. And here we are at burnout at 5.5 kilometers, and our highest point, the apoapsis, is now 7.5 kilometers. This is with two boosters. Now, the highest we've been so far was an apoapsis around 18 kilometers with 3 boosters, firing them all at once. And I'm going to show you a way to use 3 boosters in an efficient way. We could do this if we put another inline separator, stack decoupler here, and another booster here. But if we keep doing this, we will quickly run into problems. We might even have them now already. Wait, let's have a look. If the staging is set up right, the bottom booster first, then the second one, and then the third one. That's correct. We will run into trouble if we keep doing this, because at some point the one booster on the bottom will just not have enough thrust to lift all the boosters above it. So it will basically be wasted. So if we make this and launch it, you can see while the craft is lifting off the launch pad, but it is doing so incredibly slowly. So yes, we are getting a little bit of an increase in altitude and speed for this booster, but you can imagine if we keep doing it like this, the improvements are going to cease. So we're going to go back to the vehicle assembly building and use these 3 boosters in a different way. We are going to use them side by side. So we're going to delete these 2, and we're going to look for another decoupler, and we're going to use the radial decoupler. Again, it's very important to put these with symmetry because we're putting them on the sides. So we want them, now let's put them on the ballast tanks actually. We want them on the sides and completely exactly symmetrical. So we're going to put it here. Wow, it's a bit strange. We're going to put it here. There we go. And we're going to put a booster on these separators. Now we can fire this rocket in a number of ways. We could do the one booster first, and then the 2 boosters second. We're going to do it the other way around. We're going to do the 2 boosters first, separate them, and then fire the last booster. That way we can even vary our thrust a little bit. First, for getting off the launch pad, for going through the thick part of the atmosphere, we have the extra thrust of the 2 boosters, and then when we're a bit higher up in the atmosphere, we light the second booster, well, the third booster actually, the second stage, we light it, and then this can carry us higher. Of course, they will be dropped because as soon as they burn out, they are not useful anymore. So we're going to launch the rocket here. We can see it's carried up by these 2 boosters. Carried it up nicely into the air. And the separators, they are well prepared with explosive bolts and separating power to drop these stages as soon as they are spent, because we don't want to carry up unspent boosters any higher than we have to. So we're coming up onto booster burnout now, and now they're gone. So we're going to hit spacebar, separate them, and it ignites the last rocket. Now these were in the stage together, and you can perfectly well do that. Put a decoupler in a stage with the next engine, and they will decouple and fire at once, bringing you optimal efficiency and not causing you any losses due to spending time in the air without firing rockets. This is something you generally don't want to do. So we're at 13-14 kilometers already with the 3 boosters, and we can see what our highest point is going to be. It's going to be 22-21 kilometers. So this is more than the 18 kilometers we got from firing the 3 boosters all at once. Now this increase might not seem like a lot, but hey, if we look at that, there is a Idiot 3 capsule that's plummeting from the sky. This is from a previous experiment. I don't recall what that was about, but it is coming down rather rapidly. It's going to burn up in the atmosphere, I'd say. Well, that's a little bit of continuity for you there. But what I was talking about, this increase is very significant. It is about 15 to 20% in this example. And this is because we're using a big ballast tank with relatively small rockets. If you're using big rockets that get you out of the atmosphere, setting up staging properly will save you immense amounts of weight and enable missions that were hitherto impossible. So staging is important, and we have the radial decouplers and the stack decouplers. If you keep in mind a few basic tenets of rocketry, they are dump dead weight as soon as you can. If you have an empty fuel tank, an engine that's not firing, you want to dump it as soon as you can, because it is not helping you. It's only dragging you down, it's holding you back. So you want to get rid of that, and you do so with decouplers. Another one is that you need to adjust your rocket power based on what you want to do. If it is escaping from, if it's getting through the thick atmosphere at the bottom of the planet, then you want to have a lot of power, but you also want to save some. Ooh, we're crashing quite hard there. I'm not sure what I was going to say. You want more power for getting out of the atmosphere, and then once you're higher up you need less power. That's basically it. So what we have learned today is how the decouplers work and how to set up your staging to use them. Not sure if there was anything else to explain. I don't think so. I might do a third episode on how exactly to set up liquid engines and staging with that, because that's a little bit more complex in and of itself, because it has fuel tanks, engines, and also fuel ducts. But for now, I'm going to leave it with the decouplers. Let me know if you learned anything, if it was useful at all to see me explain this. And of course, if you liked it, hit that like button, hit that subscribe button, and show it to all your friends that are clueless as to how to set up staging, if you have any. Thanks for watching. This was Lorenzo, and goodbye.